Hello guys, so for today's video we will be talking about or we will be tackle the summary of chapter 7, which is IP addressing. And before we start, I would like to introduce to you myself. My name is Mark James Frago from BSIT 2107 at the Alangilan Batangas State University campus. So let's begin. So the sections and objectives of this chapter is connectivity verification. Use common testing utilities to verify and test network connectivity. So we will need to explain how ICMP is used to test network connectivity. Use ping and trace route utilities to test network connectivity. So IPv4 network address. So the fundamentals, the binary system system consists of numbers 0 and 1 called bits. So positional notation, the first row identifies the number base or radix decimal is 10. Binary is based on 2, therefore radix will be 2. The second row considers the position of the number starting with 0. These numbers also represent the exponential value that will be used to calculate the value that will be used to calculate the position value. Fourth row. And the third row calculates the positional value that by taking the radix and raising it by the exponential value of its position. Note guys, n raised to 0 is always equals to 1. The positional value is listed in the fourth row. The subnet mask. So the subnet mask, 3 IPv4 addresses must be configured with a unique IPv4 address of the host. Subnet mask identifies the network on host portion of the IPv4 address, default gateway IP address of the local router. So, logical AND. A logical AND is one of the 3 basic binary operations in digital logic. So guys, this is used to determine if the network determine the network address, and the local AND of 2 bytes yields the following results. So 1 and 1 is equal to 1. 0 and 1 is equal to 0. 0 and 0 is equal to 0. 1 and 0 is equal to 0. So we have the prefix length. The prefix length, shorthand method of expressing the subnet mask, equals the number of bits or bytes in the subnet mask is set to 1, written in slash notation followed by the number of network bytes. Network host and broadcast addresses. Types of address in networks: 192.168.10.0/24. Network address, first host address, last host address, broadcast address. So, the static IPv4 address assignment to a host. Some devices like printers, servers, and network devices are required a fixed IP address. So, it is very needed that we have the fixed IP address, because yes, we have to have a default IP address on each devices like printers. So dynamic IPv4 address assignment to a host. So let's proceed to this one guys. Unicast transmission. Unicast is one-to-one communication. Use the address of the destination device as the destination address. Broadcast transmission. Broadcast one-to-all. It means that message sent to everyone in the LAN destination IPv4 address has all ones. Multicast. Multicast transmission. So, multicast want to select group 224.0.0.0 to 239.255.255.255 addresses are reserved for multicast. So, routing protocols use multicast transmission to exchange routing information. Public and private IPv4 addresses. Private addresses, not routable, used only in internal networks, must be translated to a public IPv4 to be routable. And private address blocks, as you can see guys, this is private address blocks. Sorry guys. Classes of addressing, classful addressing, wasted addresses, and exhausted the availability of IPv4 addresses. IPv6 network addresses. IPv6 versus IPv4 has a larger 128-bit address space. 340 undecillion addresses, solves limitation with IPv4, adds enhancement like address auto configuration. So, wow. So, we have the types of address in IPv6. There are three types of IPv6 addresses. So, we have unicast, multicast, and anycast. Unicast, single source IPv6 address. And multicast, an IPv6 multicast address is used to send a single IPv6 packet to multiple destinations. And anycast, an IPv6 anycast address is any IPv6 unicast address that can be assigned to multiple devices. So, IPv6 prefix length is used to indicate the network portion of an IPv6 address. So, the prefix length can range from 0 to 128, and typical IPv6 prefix length for most LANs is over 64. So, IPv6 unicast addresses, we have global unicast, link unicast, unique local. So, these are global unicast. These are the globally unique internet routable addresses. Local link local, used to communicate with other devices on the same local link, confined to a single link. And the next one is unique local, used for local addressing within a site or between a limited number of sites. So, how structure of an IPv6 global unicast addresses. So we have a global routing prefix, which means network portion of the address that is assigned by provider, typically over 48. So we have also the subnet ID, used to subnet within an organization. And next one is interface ID, equivalent to the host portion of an IPv4 address. So, verifying IPv6 address configuration. Okay. So, we have connectivity verification. So, ICMPv4 is messaging protocol for IPv4. ICMPv6 provides the same service for IPv6. So, ICMP message command to both include host confirmation, destination or service unreachable, time exceeded, route redirection. So, we have the ping, testing the local stack. So, ping the local loopback address of 127.0.0.1 for IPv4 or ::, 1 for IPv6 to verify the IP is properly installed on the host. So, use ping to test the ability of a host to communicate on the local network. So, we have traceroute. Testing the path. Traceroute is a utility that generates a list of hops that were successfully reached along with path. So, a round trip or RTT, time it takes the packet to reach the remote host and for a response for the host to return. Asterisk is used to indicate a lost packet. So the chapter summary of this, the whole summary is the explain the use of IPv4 addresses to provide connectivity in small to medium-sized business networks, and configure IPv6 addresses to provide connectivity in small to medium-sized business network, and use common testing utilities to verify the test network connectivity. So that's all for today, guys. That's all for this chapter 7 CCNA 1 summary. Thank you guys for watching, and hope to see you soon again for our next chapter, which is chapter 8. And that's all for today, guys. God bless and mabuhay.